Right heading. Explain the term. हाँ पीयूष, हेलो, हाँ पीयूष, हाँ हाँ, निकलना है, निकाल दो, हाँ दे दो, दे दो, दे दो। हाँ हाँ, ओके, हाँ बराबर, हाँ हाँ, चलेगा, ले लो ना, एक ले लो, ठीक, और वो पुट भी ले लो, ठीक, ठीक है, ठीक। वो देख लेना अपने हिसाब से, जैसा वैसा निकाले। अरे नीचे आ गए, तो क्या करें, निकाल दे, ठीक है, ठीक है, ठीक, ठीक, हाँ, write the heading. Define moment of force. Define moment of force. Define moment of force. Moment means in physics it is called ability to rotate. So whenever moment word comes, you should think that it is ability to turn or rotate, also called as turning effect. Ability to rotate or produce turning effect is called moment. Now, who is producing that turning effect? Force. So, ability of force to rotate a rigid body. Rigid body is that body where when I apply the force, it is not changing its shape or size. That means distance between any two particles remains unchanged even after application of force. That body is called rigid body. And imaginary line on which it will rotate is called as axis of rotation. So explain moment of force. Generally they will ask this, or define. First I'm explaining, then I'm giving a definition. The ability of force, एक मिनट रुको जरा, ध्यान से देखो पहले. The ability of force to rotate a rigid body about given axis of rotation is called as moment of force. It is defined as product of magnitude of force and perpendicular distance from between point of application of force and axis of rotation. Ability of force to rotate a rigid body about given axis of rotation is called as moment of force. It is defined as product of magnitude of force and perpendicular distance between point of application of force and axis of rotation. Is that clear, this definition with you all? Then I will derive the formula. Hello?
Yes, sir.
What
Yes,
is
sir.
what is meaning of this? I think you might have done in 10th also. Ability of force to rotate a rigid body about given axis of rotation is called as moment of force. It is product of magnitude of force and perpendicular distance between point of application of force and axis of rotation. Just write, then with diagram I will derive the formula. Right.
Done, sir.
Okay. This is rigid body rotating about this axis passing through O. This is point where we are applying the force. If this distance is R, then this perpendicular distance will become R sine theta. So force is F acting at a point making angle theta with line joining. So theta के बाजू वाला side will be R sine theta. सामने वाला is R sine theta. So from this we can say moment of force, or also called as torque, comma tau, is R F sine theta. This is the formula. In vector form, it is written as tau bar equal to R bar cross F bar. Its SI unit is Newton meter, because force is in Newton and R is in meter. So SI unit is Newton meter. Okay, just draw the diagram and write everything. Completed?
Yes, sir.
Okay. Everybody has done. Can I remove this from the screen?
Yes, sir.
Yes, sir.
Yes, sir.
So we got formula R bar cross F bar in vector form, or RF sine theta SI unit Newton per Newton meter. What will be its dimension? Can you suggest? Dimension?
M1 L2 T minus
L2 T minus 2.
Because energy जैसा है ना, M1 L2 T minus 2 बराबर. If sense of rotation is in anti-clockwise direction, then torque is taken as what? Positive or negative?
negative.
Positive.
Negative.
Then it is taken as positive. If sense of rotation is clockwise, is in clockwise direction, then torque is taken as negative. Right to note.
Done.
Moment of force or torque is RF sine theta, clockwise then positive, negative, anti-clockwise then positive. Define couple and state its properties. Define couple and state its properties. See, whenever you say couple, means one or two.
2.
2.
2.
We have got shoes, chappals, slippers, all in couple. They are two. Both are equal or opposite? Couple means
Opposite.
opposite. Magnitude wise, they are equal. So if this is one, this is another. Are they couple? This is 10 Newton, 10 Newton. Are they couple?
Yes, sir.
No, they should
Yes,
not
sir.
have same. No, this is point to be noted. They should not be in one line. This is one force, second can be anywhere, opposite, but not in one line. So two equal opposite forces having same magnitude. Equal बोल दिया तो magnitude नहीं बोला तो भी चलेगा. Two equal and opposite forces parallel to each other having different line of action and acting on the same body is called couple. Two equal opposite forces having different line of action acting on same body is called as what? Couple. Clear what is couple? डिफरेंट लाइन ऑफ
Yes,
एक्शन
sir.
इज इंपॉर्टेंट, डिफरेंट लाइन ऑफ एक्शन, एक ही लाइन में नहीं चाहिए, अलग अलग लाइन में चाहिए, बॉडी सेम होना चाहिए. नाउ राइट, टू equal and opposite forces, two equal and opposite forces parallel to each other two equal and opposite forces parallel to each other having different line of action acting on the same body is called as couple. Acting on the same body is called as couple. Properties of couple. First, suppose I fix a body here, this one rod fixed here, fixed, also called as pivoted, and I apply force. Which type of motion it will perform? Translation or rotational?
Rotation.
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 Rotation. But natural. Suppose I don't fix it, but I have two equal opposite forces. Now what it will perform? Not fixed. Huh? Still rotational, because if this will perform anti-clockwise, this will also help in anti-clockwise. So dono,
Yes, sir.
that means can I say couple always produces pure rotational motion? Pure rotational motion.
Yes, sir.
मतलब वो कभी ट्रांसलेट करेगा ही नहीं, लेकिन अगर सिंगल फोर्स दिया तो चांस है if it is free to move, it can translate or it can rotate depending upon roughness of the surface. So first property I can say couple, right now, couple always produces couple always produces rotation, pure rotational motion. Couple always produces pure rotational motion. Second point, the moment of couple is product of, this we are going to prove, moment of couple is product of any one force and perpendicular distance between two forces. This we are going to prove how it is. You just write first property, moment of couple is product of any one force and perpendicular distance between two forces. Third, the moment of couple is always constant in same plane. Always constant in same plane. Thus, it is independent of, position of axis of rotation. Thus, it is independent of position of axis of rotation. It is independent of position of axis of rotation. The second, third point I am proving so that you understand what we are telling.
Independent of
Position of axis of rotation. Independent of position of axis of rotation. Everybody has written?
Yes, sir.
Yes, sir.
Show that moment of couple, is the product of any one force and perpendicular distance between product of any one force and perpendicular distance between them, or show that moment of couple is constant in same plane. So both those properties we can prove together. Yes, if you have done, then please tell I will clear this.
done, sir.
Okay. Now we are saying moment of couple. That means I should always start with two forces. Same magnitude with some separation between them. Consider a rigid body acted upon by two equal and opposite forces of magnitude F at points A and B as shown in the figure. Case 1. Let axis of rotation passes through O, which lies between A and B. That means if this is rigid body, here we are having point A, this is point B, force F are acting on both points, and axis of rotation is somewhere in between, center नहीं है किधर भी बीच में. तो फर्स्ट केस का डायग्राम फॉलोड, टू फोर्स. Hello.
Sir, yes, sir.
See, in all the three cases where I am taking first case, center O is between, फिर बोलूंगा left side, फिर बोलूंगा right side. But please, while drawing diagram, take care that direction of this forces you are not changing. If I have shown downward at A, upward at B, whether O is here, O is here, or O is here, ये दोनों का डायरेक्शन मत चेंज करना, नहीं तो रॉन्ग रिजल्ट आएगा. So same body पे forces are acting in same direction, axis of rotation किधर भी होगा तो आंसर सेम आना चाहिए, ये प्रूव करना है. So please write this statement. Case 1, draw the diagram, then I am proving. Vaibhav, when is your exam? Date is scheduled? Yes, Vaibhav, college exam date is given?
No, sir, it's not given.
Only topic they have given.
Yes, sir.
Done, sir.
One second. Huh? So with diagram you have completed, you are saying. Taking moment of couple at O, we get tau equals. This was the force acting at A. Magnitude F, O से distance OA. What will be sense of rotation? Can you tell me?
Anti-clockwise.
Anti-clockwise. So it should be plus of F into OA.
Yes, sir.
And other force is acting like this. What will be sense of rotation?
Anti-clockwise.
Also anti-clockwise. So plus F into OB. If I take F common, we get OA plus OB. What is OA plus OB equal to?
AB.
AB. So F into AB. Equation 1 is torque due to couple. So we got one single force and दोनों force का बीच का distance AB. तो ये formula आया. Now we are checking position change करने से whether it is going to remain same or it will get changed. Write these 3 lines. Case 2, O lies on right hand side of A and B, and then draw this diagram without changing the direction of force at A and B.
sir.
Yes. Point O lies on right hand side of A and B. We have to check now what is moment of couple. Taking moment of couple at A and B, we get tau equals to O is on the right hand side. This is A, this is B. Tell me what is sense of rotation at A?
Anti-clockwise.
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 It is plus F into AB. What about at B? Sense of rotation? ये point पे rotate हो रहा है वो. At B,
Clockwise.
clockwise, yes. So it will be, हाँ एक मिनट है, ये पहला वाला wrong किया. So tau equals to F into OA distance, anti-clockwise, therefore it is plus. Then this F at OB distance from O, rotating in clockwise, therefore minus. So if I take F common, inside I get OA minus OB. What is OA minus OB?
AB.
AB, yes. So this is again tau equals to F into AB. It is similar to the first one only. Hello?
Yes, sir.
It is similar to first ना, क्योंकि एक force into perpendicular distance between two force आया. Again it is not changing. पहला इधर था तो भी वही answer इधर है तो भी. Now third case I will take if it is on left side, whether answer is same or not. Yes, right. Taking moment of couple at O, we get. Taking moment of couple एक minute, at O, we get.
Done, sir.
Case 3. Point O lies on, earlier case we took on right hand side, so here left hand side of A and B. This is rigid body, this is O, A, B, acted upon by force F, taking moment of couple at O, we get tau equals to F. From O it is at distance of OA. Now tell me, it is what is sense of rotation, clock or anti? For A,
Clock.
clock, correct, minus. मतलब इमेजिन करो ना, ऐसा वो एक स्केल लेके O पे पकड़ लिया आपने, and at A you are applying force downward, so it is moving in clock. What about F acting on B वाला? O से distance is OB,
Anti-clockwise.
Anti-clockwise.
so plus. So torque is F OB minus OA. What is OB minus OA?
AB.
AP.
F into AB equation. Is it same in 1, 2, 3?
Yes, sir.
Yes, sir.
So thus we can say that moment of couple is product of force, one force and perpendicular distance between force, and it is not dependent on O. ये right left किधर भी रहेगा चलेगा, plain same रहेगा. Yes, complete third one, then I'm writing conclusion.
So,
Next conclusion writer. Thus from 1 to 3, thus we can from 1 to 3 we can say that moment of couple, we can say that moment of couple is product of one force forming couple and perpendicular distance between them, and perpendicular distance between them. Also, moment of couple is independent of position of axis of rotation in same plane, position of axis of rotation in same plane. Yes, done. Hello.
Yes, sir.
Okay. Right. Okay. Mechanical equilibrium. Mechanical equilibrium. What is meaning of equilibrium? सब कुछ इक्वल हो गया तो इक्विलिब्रियम ना. अगर टेम्परेचर इक्वल है तो बोलते हैं थर्मल इक्विलिब्रियम. Mechanical equilibrium means net force, that means summation of force acting on a rigid body should be zero.
Yes, sir.
Then it is said to be in mechanical equilibrium. Clear meaning? When you can say in equilibrium, when net force
Is equal to 0.
acting on the body becomes zero. Right. When net force acting for a system of bodies is zero, when net force acting on system of bodies is zero, then the system is said to be in mechanical equilibrium. System is said to be in mechanical equilibrium. Thus, for mechanical equilibrium, summation of F equal to 0. This we read like this, ऐसा symbol है. And we read as summation. In maths you will get summation equals to 0. Also, velocity or linear momentums, force is 0, that means momentum is constant. So also velocity or linear momentums of all parts of the system must be constant, or 0 for the system. To be in, for the system to be in mechanical equilibrium. One more part item. Also there is no acceleration. Also there is no acceleration in any part of the system. Also there is no acceleration in any part of the system. there are three types of equilibrium. There are three types of equilibrium. First, stable equilibrium. Second, unstable equilibrium. Third, neutral equilibrium. Stable equilibrium, unstable equilibrium, neutral equilibrium. Once you are done, tell me. Then with diagram I will explain what is stable, what is unstable, what is neutral. Yes, done. Na? Now we'll see meaning what is stable, unstable, and neutral equilibrium. Suppose one body is at this position, same body then goes at the top position. It is at plane position. So bottom, top plane. Net force सब पे zero है. In which case you can say potential energy is minimum. ये तो हाइट पे है ना, तो इधर मैक्सिमम.
The first.
फर्स्ट वाला ये मोस्ट स्टेबल केस बोलते हैं इसको. बिकॉज व्हेन यू पुश क्या होएगा, देखो ये बॉल को मैंने पुश किया ऐसा, थोड़ा सा फोर्स देके छोड़ दिया, ये ऊपर ऊपर जाएगा कि फिर से नीचे आएगा? फिर से नीचे आ जाएगा ना अपना जगह पे.
Yes, sir.
इधर से पुश किया थोड़ा सा तो क्या होएगा, ऐसा पुश किया तो वापस इधर ही आ जाएगा ना. This type of situation is called stable. That means when a body is pushed slightly and released, it comes back to the original position. It comes back to the original position. Then it is called stable equilibrium. Bouncer क्या लगता है? If a body is displaced and released, it comes back to the origin. It comes back to the origin. What is that called? Stable.
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 Yes, it is called stable position. Now here if I displace the body, तो ये नीचे गिरेगा, पर फिर क्या ऊपर ऊपर आएगा क्या वापस?
Nice, sir.
No.
When it is slightly displaced from equilibrium position, it will move from that position and come to the ground and become stable, never return back. So this is called unstable equilibrium. इसको पुश किया क्या होएगा, ये आगे आगे जाएगा. पोटेंशियल एनर्जी कम हुआ क्या ज्यादा हुआ इसका? ये लाइन में
उतना ही है.
उतना ही है. नो चेंज इन पोटेंशियल एनर्जी एंड नो चेंज इन पोजीशन. खाली जगह पे आगे आगे जा रहा है ना, सेम प्लेन पे. तो इसको बोलते हैं न्यूट्रल. ये स्टेबल, फिर से पोटेंशियल एनर्जी उतनी होता है, ये पोटेंशियल एनर्जी कम हो जाता है और फिर बाद में स्टेबल बन जाता है. तो इसको बोलते हैं अनस्टेबल इक्विलिब्रियम. ये न्यूट्रल, इसका पोटेंशियल में कुछ फर्क ही नहीं पड़ता है, पोजीशन चेंज होते हैं. ऑल द थ्री क्लियर? स्टेबल किसको बोलेंगे? व्हेन कम्स बैक. अनस्टेबल नेवर कम्स बैक. इक्विलिब्रियम keeps on changing the position without change in the potential energy. तो neutral. Clear? तो
Yes, sir.
देखो एकदम सिंपल है. स्टेबल मतलब कुछ भी करो उधर ही आएगा. अनस्टेबल थोड़ा सा डिस्टर्ब किया तो निकल जाएगा स्टेबिलिटी से. न्यूट्रल स्टेबल पोटेंशियल एनर्जी सेम है लेकिन पोजीशन अलग 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 है सेम प्लेन में, उसको कहते हैं न्यूट्रल. So just draw this three diagram A, B, C. Then we will write stable, unstable, equilibrium. Three cases we have shown. In all the cases, net force is zero, but their potential energy is different. Just draw the diagram. If you have completed, please tell me.
Done, sir.
Everybody has done?
Yes, sir.
Yes, sir.
Right. As shown in figure A, as shown in figure A, if the body is disturbed slightly, if the body is disturbed slightly from its equilibrium position, if the body is disturbed slightly from its equilibrium position and released, then it comes back to its original position. Comes back to the original position. This equilibrium is said to be stable equilibrium. Next paragraph. As shown in figure B, if the body is disturbed slightly then it comes downwards at minimum potential energy position and never returns back, and never returns back. This equilibrium is called as unstable equilibrium. This equilibrium is called as unstable equilibrium, as shown in figure C. when the body is disturbed it moves in the same plane without any change in its potential energy. This is neutral equilibrium. Completed?
Yes, sir.
Now last part, once again I'm explaining center of mass. Don't write, just understand, because already we have done. Then I will explain in next lecture velocity of center of mass, acceleration of center of mass. That will complete this chapter completely. And then work power energy MCQ and this law of motion MCQ will complete. That will complete our first, second, third, fourth chapter completely. Then I will start with, now next chapters are easy. Then as I told, I will start with then current electricity. एकदम सिंपल चैप्टर है करंट. सेंटर का एक्चुअल मतलब क्या रहता है? पॉइंट क्या लाइन? व्हाट इज सेंटर?
Point.
Definitely point. Yes.
Point.
Point. So center of mass also must be a point. Center of mass is a point at which, suppose this is one body, circular body, इसका center of mass इधर बोल दे. If this is one body, its का point of intersection of diagonal is center of mass. मतलब geometric center is center of mass. A point at which whole mass of body is supposed to be concentrated is called as center of mass. Body is said to be balanced at center of mass. Now, if body is balanced at center of mass, exactly what is happening at that point. So imagine we are having a system of two particles, M1, M2. One is at distance x1 from the origin and other is at x2 from the origin. Somewhere here at x bar lies center of mass, where whole mass of body is supposed to be constant. मतलब यहाँ पे net मोमेंट ऑफ फोर्स बैलेंस होना चाहिए. सो फ्रॉम ओरिजिन ये m1 का डिस्टेंस x1 है. So mass into g is called force due to gravity. Into distance will become moment of force due to gravity. Yes, Vaibhav, clear?
Yes, sir.
Mg is force due to gravity. X1 is distance from O. So this becomes moment of force about O. Same way, second particle M2 into G become moment of force due to gravity if we multiply with X1. ये दोनों का मोमेंट सेंटर ऑफ मास का मोमेंट पे बैलेंस हो जाना चाहिए. तो ये पूरा जो सेंटर ऑफ मास पे होल मास इज कॉन्सेंट्रेटेड, इसका मोमेंट और ये दोनों का मोमेंट बैलेंस होएगा तो ही हम लोग बोलते हैं बॉडी इज बैलेंस्ड. थ्रू आउट ये जी जी आई कैन कैंसल. सो आई कैन से m1 x1 plus m2 x2 divide by m1 plus m2 is x bar, which is position of center of mass. हेलो,
Yes, sir.
तो मैंने आपको ऐसा समझाया था. Consider two particles m1 m2 having position vector r1 bar r2 bar. Let r be the position vector of center of mass. Therefore r bar equals to m1 r1 bar plus m2 r2 bar upon m1 plus m. So this is formula for position vector of center of mass. अभी पोजीशन वेक्टर है तो इसका कोऑर्डिनेट होएगा. सपोज x1 y1 z1, इसका x2 y2 z2. So we wrote x bar equals to m1 x1 plus m2 x2 upon m1 plus m2, and y bar equal to m1 x1 plus m2 y2 upon m1 plus m2, and z bar will be m1 z1 plus m2 z2 upon m1 plus m2. This much we had written formula if you remember. Yes, Vaibhav, any doubt here or something else? Any doubt or it is okay for you now?
No, sir. It's okay.
Now, then we did how to find center of mass of the distributed particles. This is what we did last lecture, last to last. So suppose we have got 4 particles of mass m, 2m, 3m, 4m situated at vertices of square. So whenever you have to find center of mass, you have to select coordinate system. So assume ये base is our x-axis, ये y-axis और ये origin. तो इसका coordinate होएगा a0. This will be aa and this will be 0. Now tell me how to find x coordinate of center of mass. Formula. 4 particle है ना, तो m1 x1 plus m2 x2 plus m3 x3
3x3.
plus m4 x4 upon m1 plus m2 plus m3 plus m4. Can you substitute and get the answer now?
Yes, sir.
Similarly, you will get y bar. So center of mass we can locate. Main important was shifting of center of mass. That if you can recollect, ऐसा एक क्वेश्चन था. Just don't write it because we have written, I think. If 6 kg is moved 2 meter towards right by what distance 2 kg has to be moved so that center of mass remains at initial position. This I had explained you.
No, sir.
Okay. So 2 kg, 6 kg are two masses. By what distance 2 kg has to be moved? So that 6 kg is moved 2 meter towards right. Center of mass remains at same position. तो ऐसा बोला था, थोड़ा एक शॉर्टकट याद रखना. X coordinate of center of mass is m1 x1 plus m2 x2 upon m1 plus m2. So change in x coordinate is m1 change in x1 plus m2 change in x2 upon m1 plus. They are telling it is moved, center of mass is not changing, so it is 0 equals to m1 change in x1 plus m2 change in x2 upon m1 plus m2 किया तो 0 हो जाएगा. 0 into anything is 0. So we get m1 dx1 equals to minus m2 dx2. m2 is 2 kg. उसका shift we have to find. m2 is 6. It is moved to right, so 2 2 cancel. इसको left में लेके जाना पड़ेगा 6. Then center of mass will remain at same position. So I have completed full chapter except I said velocity of center of mass and velocity of acceleration of center of mass. Planner write down. Monday, revise by writing 2 times whatever taught in class. Tuesday, how many MCQs you have written? 140, na?
150.
150.
150, okay. So 151 to 175 on Tuesday. Can you try or you want me to
Yes,
read?
sir.
आराम से हो जाएगा, थोड़ा प्रैक्टिस करो अभी. हाँ. And Wednesday you will try 176 to 176 to 200. And Thursday 200 to end. Friday whatever doubt solved, practice. That means if you have doubt in this sums till end, that you have to practice. Saturday revise all law of motion MCQs. When I say all, difficult and all for Sunday's test. Sunday test, law of motion. This will be last law of motion test. What date is Sunday? 25/7/32. Is it first? I think. Huh? 1st
Yes, sir.
November. 1st November. Then 8th November, you will write work power energy ka MCQ test. So this completes our one session where we have completed almost 7 chapter because अपना ये law of motion में बहुत सा chapter joint कर दिया. So actually I have done circular motion for you. I have done friction. I have done Newton's first law, second law, third law. So many things we have done. So this Sunday तक का planning I have told. Next Sunday का खाली test बोला है work power energy. Clear?
Yes, sir.
How you are finding things are easy or difficult now? थोड़ा सैचुरेट हो रहा है.
Yes, sir.
सैचुरेशन रिमूव करने के लिए 11th November to 18th November is Diwali vacation. Don't study anything in this. Enjoy so that when you resume, you come with full charging. On Saturday, I will keep parents teacher meet. Timing I will post. Okay, just tell your parents. Saturday timing भी बता देता हूँ. 8 to 8:30 एक सेशन रहेगा, मतलब किसका किसका रहेगा बता देता हूँ मैं. And second session will be, or directly 8 o'clock I am giving. 8 to 8:30. Okay, this will be our parents teacher meet on Saturday. 9 to 9:30. Comfortably let everybody come. I will post on the group so that parents are know. So that's all for today. Please keep on revising. Don't feel
So I have a doubt.
Yes, say.